Today we're going to talk about length of a smooth curve. Now that may sound familiar because we did length of a smooth curve in rectangular form, but now we're going to deal with length of a smooth curve in parametric form. So if you'll recall from our previous chapter, arc length of a curve was the integral from a to b of the square root of 1 plus dy dx squared dx. If a smooth curve given by x equals to f of t and y equals to g of t on the interval a to b, if it is traversed exactly once from a to b, then L, the arc length, is going to be the integral from a to b of the square root of dx dt squared plus dy dt squared dt. Now I just want to do a little diagram showing this and explaining it. Let's say we have a smooth curve, and along that curve, I'm going to exaggerate now so I can draw this and have it fit. Say we'll pick our point, and the horizontal change here will be dx dt, and the vertical change will be dy dt. So you should be able to see that the hypotenuse of our right triangle is going to be the square root of dx dt squared plus dy dt squared. I want us to find the length of the asteroid given by the parametric equation x equals to cosine cubed t, y equals to sine cubed t. Now remember, this is really cosine t quantity cubed, and this is really sine t quantity cubed. We're going to find this for when t is between 0 and 2 pi. And we can actually sketch this a little bit by hand. Just think about your x and y values for t equals to 0. When t is 0, cosine is 1 and sine is 0. When t equals to pi over 2, cosine is 0 and sine is 1. But when t equals to pi over 4, we get 1 over radical 2 for sine and cosine. And then you have to cube it, so it's actually a slightly smaller number. And it kind of does this really interesting little shape. It's called an asteroid. And we're going to go ahead and use symmetry to calculate this. Now it's going to be important that we use symmetry to calculate it because we're going to have dy dt and dx dt. We are going to use symmetry to find the length of our curve, and we're going to multiply by 4 times the integral from 0 to pi over 2. So now we have to write in dx dt quantity squared and dy dt quantity squared. So dx dt quantity squared is going to be 3 cosine t squared times negative sine t for the chain rule. And then we're going to have to add to that 3 sine squared t times a cosine t quantity squared dt. So we're going to get 9 cosine to the 4th t sine squared t plus 9 sine to the 4th t cosine squared t dt. Let's see what we have in common if we can simplify anything here. Well, they both have a 9. Each of these has at least a sine squared in common and a cosine squared in common. I'm going to have us take out from underneath the radical a 9 sine squared cosine squared. So that's going to come out as a 3 sine t cosine t. And what we have left underneath is going to be cosine squared t plus sine squared t, which conveniently is our Pythagorean identity, and we get that to be 1. So now all we need to do is integrate 3 sine t cosine t. I am going to leave myself with the 2 sine t cosine t dt in my integrand because I know that 2 sine t cosine t is sine of 2t. So I can integrate and get 6 times negative 1/2 cosine 2t from 0 to pi over 2. So I have negative 3 cosine pi minus cosine 0. Cosine of pi is negative 1. Cosine of 0 is 1. So I get 6 units. This was length of a curve in parametric form. Now do you remember what came after length of a curve before when we did them in rectangular? Surface area. Just a reminder of how the surface area works again. Remember, you're going to take a smooth curve, revolve it around an axis, and when you revolve it, every little segment, which is your arc length basically, revolves around, and you form sort of like a thin little strip going around. So that's where we use the circumference. So I can say that surface area revolved around the x is going to be 2 pi y, but I'm going to write it as y of t because it's a function in terms of t, times the arc length, dx dt squared plus dy dt squared dt. So revolving around the x means you put in the y in for your radius, because try and picture it. This is your radius right here, and it's your y value. Similarly, you can have the surface area revolved around the y, and it's going to be 2 pi times x of t, and then the arc length is the same, dx dt squared plus dy dt squared dt. And also pay attention here that it is with respect to t, not x, not y. So I want us to find the surface area of the circle with radius 1 and center 0, 1 revolved about the x-axis. Okay, so I'm not giving you the parametric equation of this circle, so we need to come up with that. So that means I have a circle that looks like this with a radius 1, and I want to revolve it around the x-axis. So our parametric equations for a circle, it actually fits this form: a cosine t plus h and a sine t plus k. A is our radius, so in this case x equals 2 cosine t plus 0, and then y equals 2 sine t plus 1. Our parameter t is going to go from 0 to 2 pi. So this is the set of parametric equations we're going to use. We're revolving it around the x, so that means I'm going to use surface area equals to the integral from 0 to 2 pi of 2 pi y of t square root of dx dt squared plus dy dt squared dt. So just to be clear what's getting plugged in. For y of t, we're actually plugging in the function value of y. So I'm going to plug in sine t plus 1. Now I have to take the derivative of each of those with respect to time. So the derivative of x with respect to t is a negative sine t, and the derivative of y with respect to t is going to be cosine t, quantity squared. All I need to do now is to integrate sine t plus 1. Negative cosine t plus t. So I have negative cosine 2 pi plus 2 pi minus negative cosine 0 plus 0. So cosine of 2 pi is equal to 1, so I get negative 1 here. Negative cosine of 0 is a negative 1, so that changes to a plus. That cancels with my negative 1 in the front, so I have 2 pi times 2 pi, or 4 pi square units. Now, just as a last reminder here for you guys, you are going to have some homework problems that require you to integrate some of those different trig functions. So try to make sure you review your double angle formula for cosine. Remember, the ones that we needed were 1 minus 2 sine squared u and 2 cosine squared u minus 1 in order to integrate sine squared and cosine squared. Cosine squared u is 1 minus cosine 2u over 2, and cosine squared u is 1 plus cosine 2u over 2. So kind of just remember that. All this wonderful stuff with integrating is going to come back.